All right, well, let's do a couple of examples. Okay, so let's start with, let's take, this is number 2 in the textbook, I believe. And it's y double prime plus y equals secant of t. Okay, so start, as always, solving the homogeneous equation. So the characteristic polynomial, or characteristic equation actually, r squared plus 1 equals 0, r equals plus or minus I. So that means that our homogeneous solution is y of t equals, let's use a sine of t plus b cosine t. Okay, now I don't have to go through all that, oh my gosh, I feel so old saying it, rigmarole that we did to derive the variation of parameters. I can just go straight to the system that I have here. Okay, so I'm going to copy and paste. Have it right here. So for the particular solution, remember, we assumed that yp of t is v1 of t, y1 of t, plus v2 of t, y2 of t, and we get to this system. Okay, so let's apply it for this problem. Okay, so that means our matrix is going to be sine of t, cosine t. Derivative of sine is going to be, or is cosine t, negative sine of t, times v1 prime, v2 prime equals, a is 1 here, so 0 secant of t. Okay, so that's the system that we have. Now let's solve for v1 prime and v2 prime using Cramer's rule. Okay, v1 prime, let's write it as a function of t, equals the determinant of, remember, we're going to replace that first column by 0 secant of t. Okay, now actually I don't even need to do much here because I'm going to just see that the Wronskian, should have written it somewhere. So the Wronskian of sine t cosine t is the determinant of sine t cosine t, cosine t negative sine t. That's just going to be -1, right? Negative sine squared minus cosine squared. Okay, so that's just going to be -1. Okay, so that means that v1 prime of t is going to be, now here, what are we taking the determinant of? Well, 0 here, and then cosine t times secant of t is just 1. So v prime of t actually just equals 1. Okay, because here we have 0 minus 1 divided by negative 1. So let me write it that way. Okay. So v1 prime of t is 1, so v1 of t is just t. We just take the straight antiderivative. We don't worry about the plus c for this, okay? So just take the straight antiderivative, no worries with the plus c. v2 prime of t. v2 prime of t, well, that's going to be the determinant. Now, instead of replacing the first column by the 0 secant of t, we're going to replace the second column by 0 secant of t. Divided by, again, the Wronskian. So what are we going to get? v2 prime of t equals, now here, sine of t times secant of t. Secant of t is 1 over cosine, right? That's tangent. Okay, and divided by negative 1, so we get negative tan of t. Do we know how to integrate tangent of t? I think we do. Natural log of cosine, right? Okay, we just make sure we get the right sign. Sign with a G, sign, okay? So v2 of t is natural log of cosine t. Okay, let's just take the derivative. 1 over cosine times the derivative of cosine is negative sine. That is going to give us negative tangent of t. Okay, so now what is our particular solution? Our particular solution is then t sine of t plus natural log of cosine t times cosine t. Okay, remember, our particular solution was up here, t times sine t plus natural log of cosine t times cosine t. Okay, so our total solution, we haven't even considered initial conditions yet, and we're not right now, okay, is a sine t plus b cosine t plus t sine t plus natural log of cosine t times cosine t. Okay? All right, we'll see you in the next video.